So we are the brain team of the Energy Lab. I'm Jessica.
I'm Alina.
I'm Davey.
So as a team, we've done a lot of research on the brain these past years. And so we spent a lot of time getting to know the brain, trying to build up a database of knowledge. And we've also tried to get involved in a lot of knowledge in the specifics of EEG, which stands for
Electroencephalography.
And here's a device we use called an electroencephalogram. And what it has are 14 electrodes, which placed on the scalp allow us to read the electrical activity of the brain, which transmitted wirelessly to our computers allows us to use the software to both visualize and analyze the data that is provided when the subjects are doing things or reacting to stimuli.
So this provides a really great window for research opportunities. We can basically evaluate your response to anything pretty much. So what I did last year was I worked on a study that evaluated your brain on music pretty much. So when I listen to music, I would evaluate my brain responses. And from that I gained a lot of fundamental knowledge about the brain, which was really helpful this year. And also a lot of really good information on EEG itself. So that I'm trying to transfer that to Davey and Alina, and then so that helped a lot this year.
So this semester I worked on the brain project too, and the initial goal of my independent brain study was to find out whether sleep and food and time of the day affect your test-taking abilities. And so what I did before I recorded was I wrote down what food the person ate and how much sleep they got, what time they woke up, and all of those facts. And I recorded brain waves as they were solving math problems and reading a book. And here are some screenshots of their brain waves. While I didn't have the 3D brain visualizer, this software allowed me an in-depth analysis of the data. And so what I had to do is count the frequencies of each brainwave to identify what type of waves they were. And for example, like in the occipital lobe, you can see a high activity, which indicates that they're imagining the problem in their head.
Okay, so the lobe is right about here.
Yeah.
So it's in the back of your head.
And so I actually found out that there is a difference between brain frequencies on Thursday mornings after a nutritious breakfast compared to afternoons on a Friday after a heavy lunch.
Well, Alina's research focused on nutrition. My research focused on problem solving. For example, humans have different methods they approach problems. For example, the frontal lobe deals with planning, predicting, judging, while the parietal center deals with mathematical, logical, and spatial reasoning, and the occipital lobe deals with visualization. So what I did was have prompts based on each individual method of solving, and had a subject attempt to do that, and I recorded both the brainwaves as seen here, and this software allowed me to record both the location, type of brainwave, and intensity of the brainwave in a 3D plane, which allowed me to easily visualize what is happening in real time. From this experiment, I found that I was able to create a chart here which has the average data in a more concise manner. And I found that people have a lot of activity of theta waves here in the frontal lobe, a lot of delta waves in the occipital lobe, and a lot of alpha waves in the parietal center. And
So we're pretty much just measuring the levels of brain activity. You can say you're really focused, or you're really relaxed, things like that.
However, all these projects were open to many variables, as we found at the conclusion of our study. So we decided to create a more focused approach for the future, such as
the color project. So this is our new baby.
The goal of our color project is to identify different brain patterns associated with colors, with blue, red, and green color, which are the primary colors of light.
No coincidence there. So the good thing about the color project set is so narrow that it allows us to go and dive in through this tiny little lens, but it also allows us at the same time to just it allows for this possibility of basically anything. We could go into, we could construct an image of what you're looking at. Maybe we can say, oh, I know you're looking at the color red. Or we can maybe go into colorblind people, we could also see what they look at. And then possibly way into the future, we could also figure out a time where we can actually arrange these colors as pixels. So as in when you see on your smartphone, when you see a picture, now we can see from your brainwaves what kind of thing you're looking at or what you're imagining right now. So yeah.
And we're we're very thankful for all the opportunities given to us by the Energy Lab, which provides all kinds of sources for our research
Support,
projects.
everything. We wouldn't have been able to do any of this cool stuff without it, so we're very grateful.
Thank you.
Yeah,
Thank
thank you.